Hi everyone, in this video we'll have a look at how to use Embergen to create a live action visual effects shot like this. So with this being my plate, what I'll need is a camera track and some object tracks for the torches. My camera track was done in Nuke using the camera tracker node. Also make sure your timeline starts at 0 since that will make the whole workflow a lot easier. When using Nuke, it's also a good idea to set the uniform scale of the camera tracker node to 100 since the Nuke 3D scale is very small compared to other software. I use the right geonode to export my tracked camera and reference geometry to FBX for Maya, which I'll use later. I also exported the backplate to be used in Maya and Embergen. Since this is only for reference, I like to use a JPEG sequence for this in a lower resolution like 720p to maximize performance. Then I imported the FBX file into Maya, where I aligned my scene a bit better and match moved the torches with 3D models. Now let's export this scene to FBX by going to File, Export Selection, and again make sure that you use FBX start at frame 0 and that you're exporting animation and cameras. So let's go to Embergen. For a shot like this, I like to create the asset before importing anything. This way I can work with a smaller, more performant bounding box to get the scale right and the fire looking the way I want. Since the animated torches I'm about to import will need a lot more space and a bigger bounding box. I'll start using this preset I made earlier, matching a real torch. I'll put a download link for it in the description. I won't go in depth on how to create fire for this tutorial, but to summarize, I'm emitting from a capsule that's being cut out by a noise shape to break it up. I'm also using a noise force on the emitter to generate a lot of turbulence on emission, and a noise force with a lower amplitude plugged directly into the simulation to break it up a bit more overall. To get the signature fire look, you can use translucency in the flames tab of the shader node. So let's import our FBX file using the import node and browse for our file using the asset file path parameter in the asset tab. At first glance, you might not see anything. This is usually because the asset is very small, in my case because I was working with a different scale in Maya. Instead of using the scaling parameter, which is meant for fine-tuning your scale, you should use the master scale option first to do big multiplication of the scale, getting it in the right range. In this case, using 100 will make my imported torch heads roughly the same size as the one of my preset, which is good. Let's start with aligning the ground and moving the end position of our torches to be within our bounding box. This can be done using the Move manipulator with the import node selected. Let's get our tracked camera in. This is done by checking the box of the camera you want in the Cameras tab of the import node, then dragging off its connection pin to create a linked camera node for it. Since camera 1 isn't a very helpful name, I like to rename the camera I'm using to RenderCam by double-clicking on the node and changing the name, so I'm sure to select the right one in my viewport. By default, the aspect ratios of cameras is square, which is not what we want for this shot. To change this, you can go to the Display tab of the camera node and set the display resolution. This is not the output resolution, but you have to set it to a resolution with the same aspect ratio. I like dividing the resolution by 2, since high resolutions in the Display tab tend to slow the Render tab down. Let's import our backplate as a reference. This is done in the Backplate tab of the camera node. Just check Use Backplate and browse for your backplate using the Import Backplate parameter. Embergen will now detect we're using an image sequence. Let's turn Render as polygons off for now to see our backplate a bit better. Now to get the animation aligned properly, there are 3 parameters that need to be in sync. First off, in the Simulation node in the Time Control tab, we have the time step. This is the frame rate Embergen is using. By default this is set to 60 Hz, which you can also think of as frames per second. For this particular preset, it's set to 25 since fire moves very fast and using lower values here will speed things up and higher values will slow things down. This is not really a slow motion slider though, since it's the time step used for the actual simulator. But if you're not using crazy values, it can be a very helpful parameter. Now we have to set 2 other parameters to match the time step. The frame rate of the imported FBX file, which can be changed using the Override Original FPS parameter found in the Other tab of the import node, and the frame rate of the backplate found in the Backplate tab of the camera node. Later, I noticed that the backplate still didn't perfectly line up with the FBX. So if you need to offset your backplate, you can use the first frame parameter, which in my case had to be set to 0 instead of -1. You probably have to do this too if you also had all your timelines start at 0. Now that everything is lined up, let's turn off loop animation since we don't need any looping. Now I'll create a mask for just my torches in the Mask 1 tab by setting the masking mode to transformed meshes and selecting them. Then I'll disconnect the capsule I was using to connect the mask we just created to set our torches to be our emission shapes. Now it's time to increase our voxel count to fit the animation into the bounding box. This is a bit of a back and forth, changing the voxel count, moving the import node and checking with the backplate if we're not cropping or using unnecessary voxels. Make sure you won't see any smoke or fire being cut off due to a bounding box being too small, but also try to keep your bounding box as small as possible so the software won't slow down too much. If you need to use more voxels than your machine can handle, consider scaling your FBX down in the import node by half, for example, so it will fit in a smaller bounding box. When you do this, also scale all your noise shapes and forces down by the same factor. Two small bounding boxes result in less detail and smaller looking effects, of course. When we have our effects set up the way we like, we can move over to the Render tab. As you can see, it doesn't look right since we don't have our tracked camera hooked up to the render node. So let's fix that by disconnecting the default camera and connecting the tracked camera. Now I'll specify the capture types I want to use in the Capture Types tab of the render node. In this case, I'll be using direct light and ambient light to have the smoke as a separate pass for compositing. Emissive plus scattering to represent my fire, the alpha channel, and I would also like to have a mask of these torches, so I'll use alpha shapes, which doesn't give me what I need right away, since I first need to turn off the other shapes for my FBX by unchecking render as polygons. Another problem is that it has this noise cutout, which I don't want in my mask, so I'll turn show emitter off and instead make a collider node. I'll just use this for the mask, so I'll turn collider activity off and plug the mask 1 from the import node into the collider node. Now we have a nice mask of the torches, which I will later use in compositing. To render out our effect, we now have to set up our export nodes. So you can click and drag off the render node and click on export image to create an export node. Let's first set the export mode to sequence. Then set up our file path in the file path parameter. I like to use variables to make the naming convention dynamic. First, I'll make a subfolder with the project name by putting $project between backslashes. This way, when I want to export another version, I only have to save the project as torchTutorial 2, for example. For the name of the export, I'll use the $capture type variable, which will name the file after the capture type it's exporting. Targa file should be fine for this. For this export node, I'll set the component mode to RGB so I don't have an extra channel I don't use. I'll quickly check the number of frames I need in my new comp, which is 222 in my case. I'll also check the image size in Nuke since the render should match my plate. Now let's copy and paste this export node to have one for all capture types. I'll set the component mode to just red for these last two since they represent a single channel capture type. Now I'll select all these and hit Ctrl L to auto link them, which doesn't seem to work for the last two, so I'll do that manually. To export, just select all the export nodes and select Export All from the right click menu. After compositing, we'll end up with this. The problem is that our fire looks slow motion, and we can't just speed this up in compositing since we won't have enough frames and the animation won't line up anymore. So this can be solved in the following way. From the comparison I did, I know this preset had to be sped up 3.7 times. So let's go back to our import node. In the other tab, divide the replay speed by 3.7. Now in our export node, we have to multiply the number of frames by 3.7. Make sure you add an extra frame to it since the integer number might be rounded down. When this is exported and loaded into your compositing package, you have to speed it up by 3.7 again. And the effect should now be sped up with the camera and the animation still in sync with your plate. If you're not so picky and you want to speed up your simulation by a whole number, there is an easier way of doing this. Let's say we want to speed the fire up times 3. Divide the replay speed in the other tab of your import node by 3. Then keep your number of frames in the export node the same as your plate, in this case being 222. Now set the frame stride to 3. What this will do is export every third frame, which will result in the fire moving 3 times faster in the exported sequence. This way you don't have to speed the sequence up anymore when loading it into your compositing package. Lastly, I'll briefly show some of the things I did in compositing to finish the effect. Perhaps the most important thing is matching the color of your effect to the scene. Make sure it has the right brightness, contrast and saturation. For this project, I actually had a reference of a real torch I could match the colors to. So if you're able to be on set and it's possible to shoot a take where you burn a torch or something like a piece of paper, you'll have a reference of how fire should look for your particular setup. Another thing to keep in mind is how the light of the fire would be illuminating the scene. So what I have here is a mask of the elements close to the torch that should be illuminated by the fire. And I'm adding a blurred version of the flames to the image based on that mask to create the illusion of light coming off the flames. Since it's in daylight, the effect can be quite subtle. When shooting darker scenes, this is more difficult and you will probably need to use some sort of practical light on set to get believable results. When doing fire, you also need to add some heat distortion to the plate. To mask out the distortion, I basically use a blurred version of the alpha channel from Embergen and move it up a bit, since heat distortion seems to be the most visible slightly above the fire. Using a subtle glow can be nice, and what I also like to do to break the CGI up a bit and make it look more organic is to use a little distortion on the rendered element. This especially works well with fast moving effects like this. Here I'm using the extra render pass I made for the mask with the basis of the torches to do some specific adjustments on that, clipping the values a bit since I noticed the base of my reference didn't seem to have those sort of midtone values. So that's it for this tutorial. Hopefully you found this helpful and good luck making some awesome shots using